Hi, good day, this is your teacher Fred and welcome to our discussion about sequences. In mathematics we think of a sequence as a list of numbers. Each number in the sequence is called term of the sequence. There is a first term, a second term, a third term, and so on. For example, the daily high temperature readings in one city for the first 10 days of January can be thought of a finite sequence with 10 terms, like the following: -9, -2, 8, -11, 0, 6, 14, 1, -5, -11. Another example is the set of all positive even numbers. The first term is 2, followed by the second term 4, followed by the third term 6, so on and so forth. This can be thought of as an infinite sequence. To give a precise definition of sequence, we use the terminology of functions. The list of numbers is the range of the function. A finite sequence is a function whose domain is the set of positive integers less than or equal to some fixed positive integer. An infinite sequence is a function whose domain is the set of all positive integers.
When the domain is apparent, we will refer to either a finite sequence or an infinite sequence simply as a sequence. For the independent variable of the function we will usually use n rather than x. For the dependent variable we write a sub n rather than y. We call a sub n as the nth term or the general term of the sequence. Rather than use f of x notation for the functions, we will define sequence with formulas. When n is used as a variable, we will assume it represents natural numbers only. For example, list all of the terms of each finite sequence. A sub n is equal to n squared, for n greater than or equal to 1, and n less than or equal to 5. The solution. Using the natural numbers from 1 through 5 in a sub n equal to n squared, we get a sub 1 is equal to 1 squared, which is equal to 1. A sub 2 is equal to 2 squared, which is equal to 4. A sub 3 is equal to 3 squared, which is equal to 9. A sub 4 is equal to 4 squared, which is equal to 16. And a sub 5 is equal to 5 squared, which is equal to 25. Another example. A sub n is equal to 1 over the quantity n plus 2, for n greater than or equal to 1 and n less than or equal to 4. The solution. Using the natural numbers from 1 through 4 in a sub n is equal to 1 over the quantity n plus 2, we get the terms. A sub 1 is equal to 1 over 1 plus 2, which is equal to 1/3. A sub 2 is equal to 1 over 2 plus 2, which is equal to 1/4. A sub 3 is equal to 1 over 3 plus 2, which is equal to 1/5. A sub 1 is equal to 1 over 4 plus 2, which is equal to 1/6. Thus, the four terms of the sequence are 1/3, 1/4, 1/5, and 1/6. Another example. List the first three terms of the finite sequence whose nth term is a sub n is equal to the quantity -1 raised to n over 2 raised to n plus 1. The solution. Using the natural numbers 1, 2, and 3 in the formula for the nth term yields a sub 1 is equal to the quantity -1 raised to 1 over 2 raised to 1 plus 1, which is equal to -1/4. A sub 2 is equal to the quantity -1 raised to 2 over 2 raised to 2 plus 1, which is equal to 1/8. A sub 3 is equal to the quantity -1 raised to 3 over 2 raised to 3 plus 1, which is equal to -1/16. Thus we write the sequence as follows: -1/4, 1/8, -1/16, so on and so forth.
The second section in this topic is finding formula for the nth term. We often know the terms of a sequence and want to write a formula that will produce those terms. To write a formula for the nth term of a sequence, examine the terms and look for a pattern. Each term is a function of the term number. The first term corresponds to n equals 1, the second term corresponds to n equals 2, and so on. For example, write the general term for the infinite sequence. 3, 5, 7, 9, 11, so on and so forth. The solution. The even numbers are all multiples of 2 and can be represented as 2n. Because each odd number is one more than an even number, a formula for the nth term might be a sub n is equal to 2n plus 1. To be sure, we write out a few terms using the formula. We get a sub 1 is equal to 2 times 1 plus 1, which is equal to 3. A sub 2 is equal to 2 times 2 plus 1, which is equal to 5. A sub 3 is equal to 2 times 3 plus 1, which is equal to 7. So the general term is indeed, a sub n, is equal to 2n plus 1. Note: there can be more than one formula that produces the given terms of a sequence. For example, the sequence 1, 2, 4, so on and so forth could have the nth term, a sub n, equal to 2 raised to n minus 1, or a sub n is equal to 1/2 n squared minus 1/2 n plus 1. The first three terms for both of these sequences are identical, but their fourth terms are different. Lastly, let us discuss sequence with alternating signs. For example, write the general term for the infinite sequence. 1, minus 1/4, 1/9, minus 1/16, so on and so forth. The solution. To obtain the alternating signs, we use powers of -1. Because any even power of -1 is positive and any odd power of -1 is negative, we use the quantity -1 raised to n plus 1. The denominators are the squares of the positive integers. So the nth terms of the infinite sequence is given by the formula a sub n is equal to the quantity -1 raised to n plus 1 over n squared. Check this sequence by using this formula to find the first four terms.